Hello everyone, and welcome to Science 71 here on Thursday, January 10th. I apologize I'm not here again. I will see you tomorrow, Friday. Today's class is going to be similar to yesterday's class in that there will be a little bit of note-taking, not nearly as much, shorter, and more time for you to focus on working on your sea layer and studying for that all-important vocab quiz, which is tomorrow. So, yesterday was talking about motion, and how do we measure motion, how do we identify motion, and more importantly, how can we measure it and quantify it through either determining speed or acceleration. Today's class is an intro into forces, keeping it very, very simple, but part of this is based upon last night's homework, which was Chapter 2, Section 1. So here we go. Tonight's homework is going to be reading page 52 through 54, is a top-down web and questions on page 54. Now this will be the fourth and final top-down web that you will do this week. You've done a fantastic job keeping up with it, folks. Please remember that a top-down web is to give you a simple visual representation of what the topic is about. It doesn't mean include every nuance and every bit in detail, but to give us a simple approach to what we're doing here. As we take some more notes and finer notes when I get back, we'll use two-column notes, we'll go and revisit these top-down webs, and we'll add to it and we'll make it a much more finite and explanatory version of the note-taking process. So again, homework tonight, page 52 to 54, top-down web, and questions on page 54 to the best of your ability. Here we go. Newton's first law. So you've got some space on the side of your paper, your handout for today. But Newton's first law, simply stated, an object at rest will remain at rest unless acted outside by an outside force, acted upon by an outside force. And so we also have this notion that an object in motion will remain in motion unless acted upon by an outside force as well. So that penny you put on the counter is going to stay there until an outside force acts on it. Maybe the table is removed, maybe the child in the room flicks the penny across the table, whatever. Now a ball being thrown will keep being thrown and flying through the air until an outside force acts upon it. In this case here, gravity, always acting on it, will bring the ball to the ground. And so we must keep this in mind that Newton's first law states this. So forces. What is it? Is it a push or a pull on an object? We're looking for some examples. We're looking for a scenario in terms of ways to remember what a push or a pull is with these forces. So we have let's talk about the tire on a vehicle pushing against the what? The road. So it pushes on the road. Cool. We also could use things like the hand pushes on the pencil sharpener. All these things are user-friendly. So this idea that a force is a push or a pull, I like to focus on the push first because you're going to discover very quickly that there's only really one pull here on Earth. And so this push is, in this case here, anytime an object is changing position from another object. Now you also notice another thing here, net force. This idea that you can actually go and sum up all the forces involved in a situation. So let's go and treat this net force as the sum of all forces. And you may have seen this word net used before. This would be like on the outside of a container where it says net fluid ounces or so on and so forth. You're adding everything up. Okay? So I'll let you take down these notes. And we're going to head to the next slide. If at any point in time you or people need to go back into the YouTube video here, by all means, please ask the teacher involved. They'll be more than happy to pause it, go back to it, whatever needs to be done. All right? So now we're up to unbalanced forces. Now this one is a little tricky, but it's just as the name implies. Unbalanced forces. Clearly when the forces are not equal to each other. So if they're not equal, they can't have the same number. So I'm going to draw a couple of forces here, and I'm going to ask that you kind of maybe follow along and do something very similar. I'm going to have two forces in the same direction. One is going to have the value of 3 newtons. The other one's going to have the value of 5 newtons. So these forces, while unbalanced, are acting in the same direction. And maybe we'll have a box here that these two forces act upon. In this case here, what's the net force of these two forces? You got it. We have 8 newtons acting on this box. Now, if we had a similar situation, but a box in the middle with 2 ropes and 2 people pulling on these forces, one force larger than the other, 3 newtons on one side, 5 newtons on the other, I would ask the same question. What is the net force on the box here? Well, because they're in opposite directions, we want to make sure that we subtract. In fact, let's go and make that a little bit more easily read. Subtract. And let's go and put up here in the same direction, let's put add. Because that's kind of what we're saying here. We like to add. So go back to this last situation here. What is the net force on this box? Well, they're opposite directions, so we subtract. So we say 2 newtons, and in what direction? To the right. Excellent. Let's try balance forces. Balance forces. Well, just as the name implies, the numbers will be the same. So if they're in the same direction, let's go and bring back a slightly thicker line here. We have 3 newtons and 3 newtons. What's the net force, class? You got it. Because what are we doing with the same direction? We always want to make sure that we are adding. And so that if we are adding, 3 plus 3, simply 6 newtons in the right direction. In opposite directions, 3 newtons, 3 newtons. Well, if we had a box in the middle that was being pulled in either direction, unlike the last slide where there was unbalanced forces, in this case here we have balanced forces, and so we do remember that in opposite directions, what math operation do we use? Do we use addition or subtraction? You're right, it's subtraction. And so if we are subtracting these two situations, 3 minus 3, I've got 0 newtons. If I have 0 newtons, that means there's no motion. So, could we make a note here that there is no motion when there is no force? And so there will be no motion in this situation. There would be motion above because they're working together and there is a net force. So when there's 0 net force, that equals no motion. Try and add this into your notes, please, while I head to the next slide. So here's Newton's first law, again, revisited. An object will remain at rest unless acted upon. An object will remain in motion unless acted upon. I'd like you to go and take this next few moments here to go and correct last night's homework. You'll notice here in the homework we have basically 4 answers. Please do note that if they're balanced in the opposite directions, the second one here, we have balanced in the same direction, we would get motion. Balanced in opposite directions, we would have no motion. Unbalanced in the same direction, we'd have motion. And unbalanced in opposite directions, I gotta say I made an error here. I do apologize. There should be motion right here. So let's cross that out, and we will say there is motion because they're unbalanced. They don't cancel each other out, and so we would have motion. Number 2, the ability for an object to stay at rest or keep moving. That's all about inertia. The more mass it has, the more matter it has, the more inertia it has. The net force on number 3 was 0. There was a standoff. They balanced and canceled each other out. There's no motion. At number 4, I want you to look back in the notes to see if you can figure out how to go and demonstrate with arrows dictating balanced and unbalanced forces in opposite and same directions. And that should be plenty fine for you guys. Alright, if you could you please now spend the remainder of class studying for your vocab quiz as well as working on your C layer. Again, if there's anybody here who still has not picked up the C layer, I'm very sorry for you. The C layer is in the red folders on the center table, where there's also the vocabulary puzzles as well as computer paper and white line paper to practice for vocabulary techniques. I'd also ask if you guys get done with your C layer. If that happens, that's wonderful. I will definitely see you tomorrow, but if you do get done with your homework and your C layer and studying for the vocab quiz, there's a Bill Nye frame of reference YouTube video you can watch on the computer screen of mine here. It's off to the side of the green screen, just entitled Bill Nye Frame of Reference. Give that a little click, give it a little watch. Otherwise, folks, I look forward to seeing you on Friday. Please do study your vocabulary tonight, and I will see you tomorrow. Take care.